Great. So, Glenn, hi, how are you? Good
I'm
morning.
good. Thank you. Absolutely.
Thanks for agreeing to coming to the podcast. It is an honor to have you with us today
Thank
in one of the episodes of the Myths of AI. So I started this podcast because I was seeing that within the Latin America community there was a lot of misunderstanding about what were the advances of technology and what were the impacts that it could have in different areas. And it covers a whole range of topics from how to use AI in the work in organizations and between people, or how it will affect the culture of a company by having a machine that is your coworker. Now today we're going to talk about more about your expertise, which is within the development of distributed systems, cryptography, and what are the kind of advances and how AI will have an impact on that. So I will just give you the word and let yourself introduce yourself, whatever you want to share about your experience. Would be great so that our audiences can know.
Okay, well, I'm Glenn Scott. I've just recently retired, which means I'm working on other things. But I've been programming computers for 50 years. I graduated from high school at 16 and immediately enrolled in university where I met the campus computer, and I haven't stopped since. So basically, you're talking about AI, and actually, AI has really taken the oxygen out of the room. Everyone's talking about AI. It has been remarkable. I use LLMs throughout the day to help me answer questions and do stuff like that. It's much has for me has been very amplified my capabilities quite a bit, and I expect that it will amplify a lot of other people's creative abilities too. And those abilities I think are going to revolve around creative abilities. I know that people have been worried about, oh, AI is going to take my job, and AI is going to do this and do that. Nah, if you're a creator, yeah, AI may take on some of your job. However, AI will not be able to be as creative as you, but it will take on sort of the lower level, what I characterize as lower level work of creating graphics or movies or whatever. Anyway, my expertise, however, is not in AI. Artificial intelligence, in computational artificial intelligence, uses computing to do what it wants to do. And that's where my expertise has been. My expertise has been in computing. I have worked at Sun Microsystems Laboratories. I worked for System Development Corporation, which was the first software company ever. I worked there in the 80s. I worked
How
for Sun
did that
Microsystems
feel?
Laboratories. What's that?
How did that feel back then when you were
Wow. Well,
working?
back then, it wasn't at all like it is now. It was very much interdisciplinary. I worked with sociologists, I worked with mathematicians, I worked with, just regular people that didn't really have a background in computer science at all. In fact, during those days, it was rare to have a computer science at a university. I went to South Dakota School of Mines first. There was no computer science. I transferred to UCLA, and at the time, there was no strictly computer science. It was computer science plus one other kind of thing. So at UCLA, it was computer science linguistics for me. And so
Wow.
really, it was very interdisciplinary as compared to now, where nowadays we talk about, oh, you're a front end developer or you're a back end developer. Those those are completely artificial designations of roles. Back then, you worked on a computing system because you're interested in applying computational things to something you studied before. Computational linguistics, computation and mathematics, of course, is an obvious thing. But a lot of things happened in those days. And then from SDC, I ended up going to work for Sun Microsystems, and I landed in Sun Microsystems Laboratories. And that introduced me to a whole new kind of set of problems because SDC was a software company, Sun was a hardware and software company. So we were actually making machinery that other people would buy and use. And so my interests there drifted toward distributed systems, meaning a computation system that involved more than one computer, and communication, which was essential for distributed computing. So networking. And so I focused on distributed systems and networking for my 23 years at Sun. And there are some things in the questions that you sent ahead of time that I can talk about, but we can get there in a minute. I'm just giving you kind of a what's my resume. After Sun, Oracle bought Sun, and I worked for Oracle Labs for a few years, and then from there I moved to Xerox PARC, which has been a very famous place for a lot of computing advances have happened at PARC, and I got to be part of that. And then more recently, I moved to Intuit, a finance company, a financial tech company. I did not do finance tech. I can't do your TurboTax. I know nothing about TurboTax. I can't do QuickBooks. But I worked there in the sort of the research and development portion of Intuit, looking into the future. So really, all of my career has been focused on what's next. What are we going to be able to do next? And I'm still doing that today. This afternoon, I'll be doing that.
Well, that is a impressive resume, and
Thank you.
I know that your contributions to the ecosystem and that your research had a big impact in humans' lives. So, um, probably many of the people that are going to be watching this don't know what distribution systems are and how they affect our daily life. Would you like to
Yeah, I
share?
can explain. I can explain. So computers, a computer, like I'm using a laptop right now. It's. I'm going to say this roughly. It is a single machine. It's actually not. There's several computers inside here. It is itself its own distributed system. But a distributed computing system really is more than one computer working with other computers to solve a particular problem. So, for example, your desktop computer is going to have a central CPU, which is going to do most of the orchestration of the rest of the computers on your cards. You're going to have a GPU, graphics processing unit. That's a whole another computing system. But the two work together to accomplish the job of making your display work. Well, that's fine. But sometimes you can have a computing system which can do more work, even though the computers are all doing the same thing. You can divide a problem up and separate it out to multiple computers, have them work on it independently. That is a distributed approach to solving a problem. Other times you need reliability. You can't rely on just one computer. What if something happens to that one computer? And what happens to the overall problem solving then? What if you're trying to land a spacecraft on Mars and that one computer dies? No, no. You need to have multiple computers working on the job at the same time, such that if there is a failure, something you have, you have a backup, and that's another computing approach, a distributed computing approach. And my work was kind of in the area of fundamental things like storage. In the early 2000s, I was working with two colleagues of mine, Rafi Ram and Germano Coroni. We worked on a system called Beehive, and Beehive was a storage system that used many computers. The problem with using many computers is oftentimes you can't afford to get many computers because they cost a lot of money. But we did use, I think it was University of Pennsylvania's, they had a computing laboratory where we were able to amass 300 computers, which was far short of our capacity, but we proved what we had to do. And so Beehive was a way to store data. And if you had a failure of certain number, even upwards of more than, or upwards of less than half of the computers, if they crashed, you could still have all your data. And so that led to these sort of object store ideas, object stores. And those continue to exist. An object store typically is a write once and then read many. So you create the data in the store on these computers, and then you can continue to read it, but you can't update the data. Well, okay, why not? Let's figure out how can we update that data. And so coincident about that time, Berkeley, University of California, Berkeley, was working on a project called Ocean Store. And we connected with them. We actually funded their laboratory for at least 1 or 2 years to come up with a read-write object store. Their ideas were called Ocean Store. And we transformed our Beehive system into Celeste, which became a read-write store for data that could hold exabytes. I think I think we figured out in the end we could probably store all of the data if a video had been taken of mankind since the beginning of creation. We could probably have stored all that video. So
Wow.
it was a very large system, and we worked on
All
that
of
for
the
a while. And
history could fit
there
in
were
there.
lots of interesting algorithms that came out of that. There's a paper that I reference on my LinkedIn profile paper about the Celeste object store. I forgot the title of the paper, but anyway, there was a description of how that worked.
Glenn, at that point, when you did the Celeste project, what do you think was the biggest impact into how people could use internet solutions, software solutions that were being developed at that time, so that somebody that's in the audience can relate
Yeah,
to
sorry, I'm going
what
off on
was.
this. I think what
No, it's
happened
okay.
there,
It's my
I think
job
what
to be
happened
here and
there,
try to do that.
we enabled through that work and the work of others. We weren't solo in this endeavor. I mean, we had our folks at Berkeley. There were folks on the East Coast at MIT working on this too. I think this unlocked a lot of what we now are experiencing through regular computing as a service. Your Amazon AWS, your Google Cloud, these things were probably enabled through other things too, but these storage systems, I think, enabled that storage in the cloud. And yeah, and that went on. I mean, that went on for a while. We actually turned Celeste into a general purpose computing system rather than just storage. So we had a computing system that, I'll tell you a funny story. So we had a computing system, and this turned out to be at Oracle where we had more computers. I put together a network of 40,000 computers in this Celeste-like system. We changed the name to Titan. So Titan had 40,000 computers. Well, of course, part of the design and the philosophy of the design of these kinds of distributed systems is failure is normal. Failure is not an exception. Failure is normal, and you know what to do when a failure occurs. Well, in Titan's case, when a failure occurred, the data was migrated and reduplicated. So it turns out that in the end, 40,000 computers running Titan, I couldn't take it down because if I took down one computer, another would pop up. So I had a problem for a few days with this. It was obviously a very resilient system. I had to actually push a change to it so I could take it down. So these kinds of things continue to exist. People are still working on these problems, although
Can
they're
I
not
ask
going
you
to.
something
Sure.
based on what you said? Like, it comes a question to my mind. You know how AI is being designed and built, and everybody's pushing towards
Yeah.
AGI and how these algorithms learned on their own. And this that you say about the storage and about the failure, and AI is pretty much like learning and failing and knowing what goes wrong, so then you can teach it what goes well, and it has a reward system. So, how do you think there is like an all this ethic concern of OpenAI employees leaving the company that work on security? How do you think at that time the problem that you encountered with this having to redo all the system could have a parallelism to what we are going through right now?
Yeah.
And how did you solve it at that time?
Well, first of all, keep in mind what I was working on did not meet real people. It met, us, our development team. So it
Okay.
wasn't like we made this and we handed it out to people and had them subscribe to it and oh gosh, we can't kill it. It's continuing to go. It wasn't like that. So that's one thing. One thing. How do I say this? So, like I said, AI right now has everyone's imagination because it is the closest thing that people can relate to with computing. Most people. There are people who have no idea how computing works. But AI has sort of bridged that gap. Computers are over there and it can talk to me and I can talk to it. That has opened up a lot of exposure to people who are not going to be themselves careful. And so I think the AI's rush to get in front of everyone and then be in everything is a risk because just like Titan, it was cool. I had the system running, and then it's like I can't take it down. These experiences have not they haven't had these experiences, and the push to get technology out to people, which is really cool, at the same time comes with risks that maybe are unknown at the moment. And so the consumers, people, they need to be careful too. You can't trust everything. I mean, notice on the Chat GPT website now it says something like Chat GPT can be wrong. Be careful with answers. That's very true. If you ever get an LLM out hallucinating, you can end up with all kinds of trouble. Anyway, I hope that answers your question. I'm concerned about that the rush to get these technologies in front of people who don't know how to use them or blindly trust them.
Okay. Yeah. Well, so now I'm gonna move a bit into the work that you did on content focused models and how you innovated within um, traditional IP based networks to this kind of models.
Mm.
And how do you think they have an impact in, although it sounds technical, into how we use internet and how the cloud was developed and how all that process happened, like, and how is today this different kind of processing being used for a higher need of computation that AI have, if I'm doing the question correctly.
I get what you mean.
Okay.
So, what you're talking about is when I was at Park, I worked on content-centric networking, which was a project at Park that was funded by Park. And so, what does that mean? So, right now, when we talk about networking, like we're communicating over a network right now, we use IP, the Internet Protocol. The Internet Protocol is very much like the old telephony system, which means as a kid, you probably had a house phone at the house, and it had a number. And if someone wanted to call you, they called your number, and it rang, you picked up the phone, and you answered. If you weren't there, tough. It rang, no answer. And that's IP. That's how IP works. Every node, every computing device on the internet will have an IP address. There are two forms of that IP address, IP version 4 and now IP version 6. IP version 6 just has more numbers. Think of it that way. And when you transmit data, you have to address it. You have to put on the data packet that's being sent the address of where it's going to go. The network has routers which will route that packet to its final destination. If that final destination doesn't exist, tough. Nobody was there to answer the phone, so to speak. So really the internet protocol, or the internet, really models very closely the old telephony system, and even the current telephony system. Everybody has a phone number. Now, over time, of course, we developed other technologies to facilitate making that easier. When you go to Amazon.com, you're not typing in the Amazon IP address. You say Amazon.com, which really is it really is a phone book lookup. The domain name service is a thing given a name, it will translate that to an IP address. And so that's how it goes. And the problems with this is that it is very wasteful. That is to say, if you're Amazon and you have potentially millions of customers visiting your website right now, you have a variety of things going on. Number one, your website is not a website; it's a distributed website. There are many machines involved in this website, and the fact that they are working together is unseen to you. But you're going to go to an IP address, all right? And now we use encryption. HTTPS is using an SSH or a TLS encryption, which means that your connection and my connection we cannot reuse each other's data. So if I'm looking for a pair of socks on Amazon and you're looking at the same pair of socks, Amazon's going to take that image of the pair of socks, it's going to put it in a data packet, encrypt it, put it in a data packet, and send it. And that costs time and energy because the encryption has a different key. They can't reuse. They probably have mitigation things in there to do stuff better, but still they're sending out individual, unique packets to every customer. So go forward a little bit. Content-centric networking is not about the IP address. The content-centric networking is about data, just a chunk of data. It doesn't have to be big, just a chunk of data. And by data, I mean, bits. A chunk of data that has a name. Now, by a name, I don't mean like Glenn. I mean a name which is also a big hash, right? A big number. That's the name of that data. No matter where that data exists in the world, it will have that name, all right? So what you do is content-centric networking. Instead of having an IP address that is forwarded or routed, you have an interest. So an interest is a packet that says, here is the name of the content I need. Please get it. Well, this changes. You're not sending this packet to an IP address. Now you're sending it to what's called a forwarder. And the forwarder, it has a big table of names, and it knows the names it knows, and then it knows where to go for other names. And your packet will route, and I don't want to get into content-centric networking routing just yet, but it will route to a place that has that packet, has that name. And that name will come back to your machine along the same path that the interest went. But as it goes back, that packet can be cached or stored on that forwarder. So if I ask for the packet again, I may just do one hop boop to the forwarder. I don't go all the way to Amazon and get it. I get it from the last forwarder in a manhole down the street.
Well,
Well,
this
this
is a
changes
huge efficiency to how the network
exactly.
works.
So, and if you and I are neighbors and we happen to be using the same forwarder and looking at the same pair of socks, and the pair of socks image is in this content object with a name, it can come right out of the manhole. It doesn't have to go to Amazon.
You have a
So,
gift for explaining hard things, I have to
thank
say.
you. So this
It's
this is
very graphical.
this is an amazing improvement, and particularly now with mobile networks, right? Mobile telephony, your cell phone, if that used CCN, and you're downtown San Francisco and you're looking at your email and a bus drives by, interrupts your cell phone connection, you drop a packet, your phone can ask for that packet again and it can come perhaps likely from the cell phone tower, not all the way back to your email server. So these
Wow.
kinds of things drastically improve the capacity, resiliency, and speed of internet communication. Now, Park is no longer working on CCN, but the concept of CCN or named data network continues to exist through an NSF-funded consortium, the NDN consortium, which is run out of UCLA. And they continue to work on what are the best practices, what are the best ways to do things with these kinds of networks. It'll be a while before we see these networks in commonplace, but they do exist. We did have a version of this kind of network that ran on top of the internet protocol, and we could address things by name. And it was just astounding to us the kinds of things we could do. And it was astounding to me the kind of demos we ran where someone would actually go in and just start ripping out cables,
I can
and
imagine.
it worked. It was just, you know,
Are some kind, are some of these concepts and techniques applied into the computing of AI networks in itself, or you think
well,
there are separate matters?
I think they're separate matters. However, keep in mind my expertise is not in AI, and you know the thing is, every well, I'm going to say every a lot of research consists of taking two different things and mashing them up. So, you know, an LLM AI or some kind of learning thing mashed up with content-centric networking, that's an interesting project. I don't know what could come out of that, but I am sure that there's some students somewhere looking into exactly that because these kinds of things, the AI stuff is very interesting. Content-centric networking or named data networking is very interesting. Mashing them up could come up with some interesting things. You know, mashing these things up with blockchain. And
Exactly.
and
That
I
was
don't
my
mean
next
blockchain meaning
question.
Bitcoin. I'm not a fan of these concepts of things that have value that have no value. But blockchain itself, it's a very clever way of proving the order of things and that nothing has changed. So
Precisely. How could
blockchain
this
is
merge
maintaining
with
order.
blockchain and uh, you work on cryptography? Would you like to tell us about how you work on cryptography and how these concepts could merge with blockchain for decentralization of
Oh gosh.
storage? I know
Yeah.
it's
So
a very
so
huge.
my work on cryptography was mostly around using cryptography in a protocol, meaning some exchange between one or more parties. For
Yeah.
example, in the Celeste system, when you updated a file, since you could, I had to have a way of having different cooperating nodes in the system agree on a particular value. And I did that through a variety of ways. And one of the ways I used was through some cryptographic techniques. I did not do much in terms of cryptography protocol or cryptography algorithms. I did have some experiments with using the roots of a polynomial to have more than one key to a particular thing. But anyway, that really didn't go anywhere. But so blockchain. Okay, the biggest thing that blockchain brings to the table is that you can prove that something happened, in what order things happened, because you can't change the order, and that nothing has changed. Now, when I say nothing has changed, what you can't prove is that is the last thing on the blockchain really the truth? You have to add one more thing, and then is that thing, so you always have a fuzzy edge to the blockchain. I don't think a lot of people understand that. The Bitcoin blockchain handles that in a particular way. Ethereum their blockchain handles that in a different way. So there are algorithms to try and ensure trust in the last element of the blockchain, but never mind that. The fact that I found blockchain interesting because I could prove things happened in an order, and nothing changed. And so I, at Intuit, I built out a system with some colleagues, Roger Mike and Mike Gabriel, and a few other folks helped. We built a system called Blackflower. That was a way that we could store events in a provably ordered way. And that was valuable for a variety of things. Later on, I used that to actually store, kind of like GitHub, but different, store the state changes of a variable. So you could always have history of a variable's values. You could go back in time. These things were kind of cool. And these ideas were brought out of the work I did at CCN at Park, which in turn was sort of from the work I did at Oracle and Sun on
With all these spikes, so many questions in my brain. I'm trying to prioritize and make a thread of many things that I want to ask you. But for instance, I'm sorry that I go back into the AI. When you tell me about all these ordering and the validation and the proof, and so to trace about what AI produces and from where it gets the data to producing that to enable a verification and a proof of knowledge about what is being released. How do you think this kind of technologies could have an impact in 20 years, let's say, on the generations of these agents and how they may hallucinate or not hallucinate to trace the veracity of what it's being created? Because in 20 years, mostly everything is going to be created by AI. And how do we know from where it comes and why it is inferring that? Because could this kind of cryptographic techniques be used for this matters?
Well, cryptography can't tell you the truth. It can only tell you what it was told. And the same for AI. It can't tell you the truth. It can only tell you what it learned from its training set. So, and again, I'm literally thinking about this on the fly. There may be ways to okay, so here's something that I think would be useful to know is explainable ways of AI. You ask a question, it does something. Maybe it says something to you, or it detects something and it does an action. Why? If you go back to sort of the roots of AI, at least one of the roots, the perceptron, which is basically has the more modern name of neural network. It's a statistical thing. It really is statistics. Given this as input, here's the output. If it's wrong, you're training it. If it's wrong, you do what's called backpropagation to readjust the balance of the weight, right? But then when you're done, okay, it's good enough. And then here's the input, here's the output. And someone says, well, why? You can't answer why.
No, it's
Because
black box problem.
exactly. So if you stored perhaps the values at each iteration of the training, and you stored them in sort of a secure way, like say on a blockchain, that could be sort of a certificate. Here is the training that we did, and here are the steps, and you could have other tools that validate that training. whether or not the backpropagation was successful, that could be something. Yeah, and even now these LLMs, as fancy as they are, and they have lots of layers of tech, which impose techniques on things, but really inside of them there are these large backpropagation neural networks, and they're huge because somebody was smart and invented the GPU, which was originally designed for graphics processing. But the little processors then there were also very good at doing a neural network. And that was a very fortunate find. And so that's why NVIDIA is, selling out of great GPUs, not for graphics, but for AI. That's exactly why. And yeah, so there's an idea. I could probably come up with more if I thought about it some more. Um, but yeah, proving the training set and the steps that were taken might be valuable in developing a system that can explain why the network chose an output.
How do you think this could have an impact into um, the primary users or beneficiaries of these cryptographic chains could be more agent users than human users for the sake of decision making in the future within different systems that organizations will have made of all these agents?
Well, I'm not sure. I just so for everyone's kind of like listening in on this, the agent is usually a computing device or computing software that acts on other things. So an agent itself could talk to an LLM. I had a chance to play with more than one LLM a while back last year, and I created agents. I wrapped an agent around them, right? The agent, so they could act independently, and I connected them together, and then I induced a conversation, and it went back and forth, and it ended up in nonsense. But an agent could do things. An agent can say, "Here are the conditions I see. I see that something is moved in the front driveway, and it's after dark. I'm going to turn on the light." That's the job of an agent. That is a simple agent. Now, there could be much more complex agents, ones that have, AI in them. I use air quotes here. Sends all kinds of things. Someone at home, someone not home, whatever, all kinds of things. Time of the year. I mean, I'm making this up because the agent may learn to do things differently, but it can anticipate things. It can do things. So I think the future of AI, as much as we enjoy using them for our own selves, I think the future will be agents, and I think agents will take on more and more normal things, whether it's turning the lights on or watering the flowers or feeding the dog. Yeah. Now you have to decide if that's how you want your life to be, because it does. These agents will actually remove some of your agency, your own agency. But
Yeah.
yeah, I think agents would be lots of places, and explainable AI is going to be critical. If you have agents in your car helping you self-drive your car, and there's a car accident, why is going to be an important question, and an answer is needed. And I don't know anything about Tesla or Google's or Waymo's self-driving car tech, but they are using AI related things. I don't know if I answered your
Explainable
question. I just
AI is one of
talked.
the things that I enjoy the most. Like the explainability of how the algorithms decide things and opening them up and seeing how the monosemanticity of whatever very technical aspect, how it was inferred. Um, it was very nice. I was explained a paper by one of my friends from high school that is very technical, and he explained it such in a nice way about how the LLM predicted the with the monosemanticity, and when you broke it up and when you started predicting how the vectors started having this kind of triggering when you talked about concepts that were related to some of the training words that were used in some cases, but in some others they didn't. And
Mm-hmm.
you had to understand how these concepts within the prompt engineering of what you were doing
Yeah,
were
yeah.
sometimes triggering those kind of vectors. And it was very graphical, so interesting. But that is another day conversation. Um, I have a bonus questions for the last question
Okay.
that is not related to AI, but I want to know what you think about and how you think, probably not for the next 5 to 10 years, but I do think that from 10 to 20 years, it's going to be a very central point of how we evolve in technology. And do you think decentralized content networks have an opportunity at competing with centralized networks like Amazon, Google? When do you think it's going to happen? How do you think it's going to be possible, if it's going to be possible, that they replace them? Because they are the big four, and with all this AI and with all this need, and there's going to be robots doing all these things in our daily life, and those tech giants were not made for having the capability of supporting all this processing involved in other kind of tasks.
Right. So here's here's an umbrella. Here's I'll start with an umbrella sort of overview of what this is about. So in the oh gosh, this must have been late '90s perhaps. Mark Weiser at Park had this idea of ubiquitous computing. That is computing everywhere. And we're kind of there. I mean, we have computers. I don't know how many computers I have in here. Many. There are probably things in here that have computers that I don't even know have computers. But that inspired me when I was at Sun on this concept I called public utility computing. Meaning, just like you have electricity and an outlet in your wall as a utility, or water in your pipes in your house as a utility, what if you had computing as a utility? Well, that meant that you didn't have your computer here, it would be over there somewhere. Your storage would be over there somewhere. And you would have a connection to that, but you wouldn't own it. And that was my idea of public utility computing. And that was sort of the overarching rubric under which Beehive belonged, Celeste belonged, Titan belonged. That overarching idea was propelled my ideas in the storage and computing things there. And coincident with that time, we saw kind of some public utility computing. Amazon, which was a bookseller early on, later became a retailer. Uh, they built out a very large computing infrastructure to support that business. And I think someone, I don't really know who, had the idea, hey, why can't we sell some of this to other people? Maybe we can host their stuff too. And that, to me, that's public utility computing. Even so, it looks like it's central. It itself is distributed among Amazon. So Amazon runs lots of services now, compute services, storage systems, databases. They have an AI system, a
So it's
variety of
kind of
things.
decentralized within the
Yeah,
centralization.
it's behind the AWS wall, but itself is also a big decentralized computing infrastructure. Same for Google. Google, they had their original algorithms for doing crawling the web and then storing all the back pointers to pages that represent them and give them page rank. This was their early idea. Of course, now that whole system has grown into a very large distributed search system, lookup system, which they have done too. So keep in mind that these are centralized in terms of the business model, not necessarily in terms of the uh, technology. So they're probably decentralized, I'm certain of it, and they use a lot of decentralization techniques. So the business model, though, makes them look centralized, google.com or aws.com. So that's sort of the umbrella. Now, really, for things like CCN or contract, there needs to be a business model that drives that. Because we're not going to get new kinds of networking unless that new kinds of networking enables some new kinds of business. Because the internet now is business. When Internet Protocol version 4 came out, Internet Protocol version 6 came, well, I'll leave 6 out. When 4 came out, Internet wasn't actually a business. It was still a research project. Started to become a business, and then it grew, and that necessitated the development of IP version 6, more addresses. But even so, the internet itself was not a business model apart from, say, Cisco and a few other internet infrastructure providers. So for CCN or NDN to work in a public way, we need some model, a business model that helps them. And that can happen. You pick up your phone and you watch let's say you're a Verizon customer and you want to watch a Netflix movie. Well, hey, that's an opportunity for Verizon to deploy CCN or NDN in their internal network to provide video packets to phones because that's going to be expensive. Video, first of all, is very trafficy, right? And cell phone towers out in the middle of nowhere, they may not have the capacity. So there's a business model that might help. But people need to watch a lot more video on their phones, I think, to make that work.
And the video needs to be anywhere, like within the application, within the SDK.
Yeah, exactly. It needs to be everywhere. Or YouTube, same problem. So I think for these kinds of some of these new developments may not gain much traction until there is a business need. And so, and of course, making a business need would separate a business from another business. So, are they compelling enough? Is it compelling enough for Verizon to deploy CCN or NDN for video on their networks because their customers would find that so compelling that they would drop AT&T or T-Mobile or whatever they have and go to Verizon? That they would need to prove that that's worth it.
Yeah. I do see where you come from. I'm thinking from the user experience of
Yeah, so
what
the user experience
moments.
would be vastly improved with something like CCN or NDN. I'm certain of it. I saw it with my own eyes, and yeah, unfortunately, users don't necessarily make business, but yeah, but yes, the consumer, absolutely.
Well,
I
the
believe they would,
consumer, like the
yeah.
person that is having that kind of benefit in the like velocity of how they receive video in their phones, like how would that change? And when is it that I'm bothered as a consumer of video in my phone about not being able to see the
Yeah.
video properly?
Yeah, exactly. What is the benefit to you? It's an entertainment mechanism now. It's not essential to your life. Maybe if you're a 16-year-old kid, it might be essential to your life, but normally it's that kind of stuff is not essential. It's entertainment.
Yeah.
Essential would be medical. Are there medical benefits?
Yeah, but maybe
Finance?
as the creator economy grows with AI, like grows into AI, the amount of available content for business purposes is going to scale a lot. It's one of the
Yeah, that's an
problems that
idea. That's a good idea.
I solve with my startup, like the processing of all the data about the ads to make better ads with AI in real time. So I'm thinking about this because I was seeing that the attention times drop. So for business purposes, it's like you have less time that every people consume each ad, but you have more amount of content released into the internet and that is available for you to watch. So,
Roger, Mike, and I have a patent on assembling ads dynamically in a CCN network.
oh, I'd
Assembling
love
the
to
ad
see it.
dynamically.
I'd love to see it. That's
So it
so
was
interesting.
we could essentially program the network, so to speak, to do particular things when certain events happened, and the interests would change, and you would assemble. We got it down to a personalized ad, so you could watch the Super Bowl and you would get personalized ads for you.
Wow, that's amazing. I think it's a conversation for another day, but I would really like to know about this patent. And but
Sure.
see, it's very easy to talk to you. We are like, I know you have a meeting coming up in a few couple of minutes, so thank you so much for this enlightening conversation. It was
Sure, you're
so
very welcome.
interesting to learn and hear from you. I appreciate very much your time.
Well, thank you, thank you. I'm glad you enjoyed it.
Super, super enjoyed it, and well, have a great day.
All right, thank you. You too. Bye
Bye.
bye.